Hi, students. So I'd like to just make you practice. So I'll help you to practice making Lex inputs. So as covered in the last lecture, you have learned how to make a scanner generator or a scanner using Lex. So Lex input translates the scanner, translates the input into a scanner. So let me just review some of the contents of it using MinJW. So let me share this MinJW screen. Actually, MC is a screen. So I have two files, and one is simple.l. So make it take a look of simple.l. So it is very simple because it only consists of 5 lines of input, but it seems very powerful, even if it is very simple. So as you know, the Lex input is divided into 3 parts. One is the declaration. So the declaration part is empty. And the second one is the pattern action. Pattern and action. So here you find a simple pattern dot, and the action is just echo. And third part is the auxiliary procedure. So the auxiliary procedure, you need YY which is just returning 1, and you need the main function. So you want to compile the Lex output as a standalone code. So this means that for any character, so this is any character excluding the new line. So for any character excluding the new line, you are print echo. So actually this is the default action, but just print a lexical token, which is also known as lexim. So print lexim. So if I want to execute this, you can make it. Sorry, I have to change this into mouse. So if you execute a flex simple.l, then it will generate lex.yy.c, and you can compile it lex.yy.c. So a.exe, sorry, in the current folder, a.exe is executed. So when you type something, this is what? What is this? So it is echoing itself until the input end marker. The input end marker is Control D in MSys, and in Windows you can use Control Z. Okay, so let me just change the simple.l. So you are echoing a singleton lexim, but you may echo it in double. So if you make flex simple.l, and you'd like to make this is lex.yy.c, and executing this, this is flex. This is flex. So it is printed in twice. So the same thing can be applied to, how about a.exe is accepting simple.l. Okay, so every character is doubled up since it is printed twice. So I said, even though it is simple, you may change the pattern. 0 or more repetition of any character except new line. So it will be echoed twice. So it is quite different. It shows quite different behavior. So let me just make a makefile because it is tedious to write every time to make a.exe. So you can make a makefile. So you know that lex.yy.c is generated from simple.n. So how can you do that? Flex. So let me just, sorry. X.y.c is depending on simple.n. So I want to just, so let me just try this because in the old makefile, you have to use tab instead of 4 spaces, but currently it is set 4 spaces. So let's just try it. Flex simple.n. And the target you want to make may be simple. So it depends on x.y.c and the command for it gcc x.y.c and the output is simple. So simple.exe was simple. So let me just try this. Once you can do that, you can make, okay, so it seems wrong for, oh, sorry, makefile. So let's just unset. What to set is it is expand tab. No expand tab. So set no expand. Okay, so you may safely use this. Okay, so it seems fine. So let's make again. So you are executing simple.exe. So this is what. Then this is what is repeated twice. This is what, this is what. How about this? Is space here. How about this? How about this? It's repeated in twice. Okay, because you are matching any sequence of characters just before the new line. Okay. So the lexeme here, in the previous case, T is a lexeme, but in this case, your lexeme is corresponds to here. So this is matched to any characters in repetition. So it is lexeme. It is a single lexeme. And for the second case, this is also matched to here. So this is another lexeme. Okay. So the lexeme is printed twice using your echo command. So any questions up to here? No questions? Then I switch to the screen to the handout of today's laboratory work. It seems there's chatting. Could you show us make file one more time? Okay, sure, I can do that. So beware that in the make file, you should use tab here. This indentation should be a tab key, not spaces. So actually, it is. I'll explain the format of this make file. It is much like this target with colon, and here is the dependent files. List of dependent files is here, and this is with the tab up here. This is the command how to build the target. So in order to make it simple is dependent on lex.y by the c. So in order to make it simple, you have to compile it with lex.y by the c with output to simple. And lex.y by the c is a target. So in order to make this, you have to make lex.y by the c. So it is dependent on simple.l. And how to make lex.y by the c? Just executing flex on simple.l. Okay. So let me switch to the handout of today. So I'll enlarge this a little bit. Okay. So today you are going to use lex and flex. Once you install the MinGW with the developer toolkit option, and you can use flex, an improved version of lex. Actually, flex stands for fast lex. So lex is a lex kernelized generator, as you know. Actually, it is the details of lex is that from this sequence of pattern I and action I, for several pattern and action I, you'd like to your lex is generating a subroutine, a procedure which is called YYLex. So the YYLex is invoked here. And for the input, the YYLex is using get character, but YYWrap is used for handling multiple input files. So the following flex input is representing an echo program. You have seen an echo program here. For any character except a new line character, it is printed to the standard output. How about, however, the new line characters are printed in default because the printing to standard output is a default action. Default action. So in order to suppress the default action, you have to make another pattern. So let's add another pattern here. Let's add another pattern. For new line, do nothing. So you can do that. So let me just switch to the previous MSys window. So you can use simple.l. So you can rewrite this, write merge.l. So you have to make merge.l. So merge.l is printing echo for every character, but for new line, it is do nothing. Okay? So you can edit, make a file. So you, in order to use merge, you have to compile merge.l. So that means make, then merge, execute merge.exe. Sorry, output is simple. So sorry, it's not change it. Make file. So the output is merge. Make again. So merge.exe. This is a sentence. And you know that the cursor is in the same location. This is another. Okay. So the effect of this can be considered that merge.exe is accepting merge.l or simple.l, anything will do. Every line is merged as a single line. Okay, because you didn't take the default action. So let me show this. This means, sorry. So this means suppress the default action. So default action is just, the default action is just echo. But for all the characters, you are echoing it as is, but for new line characters, you're suppressing the default action. Okay? So let me switch to the handout again. And use Lex input can have C declarations. Lex input can also have declarations in C language. The above program does not have any declarations, even with the C declarations, but in this sample code, sample input, I'd like to add C declarations. So you can see that you can include C declarations by the pair of this one and this one. So you're opening percent brace and closing it percent brace using a C declarations. And you know that this is another section for pattern action. This is the section of auxiliary procedure. So let me just erase this a little bit. So that means you can think about that your output is created depending on this input. So let me show this. Let me simplify that this is the part of lex.yy.c. Then this part, C declaration part, is copied from the beginning of the lex.yy.c, copy it to here. And for this, know that your lex is generating yy lex. Correct argue. Were you planning on the handout? The handout is available in your NeoSPAN. What is the actual causing the input stream to enter? So it is entered from standard input, meaning what part is allowed to give input to the program. So there's no part of the input here, but YYLX is assuming get character. So inside of YYLX, it is using get character for the input. So it is assuming the standard input. Are you satisfied out of here? Okay. So these things, these auxiliary procedures are copied in this side of YYLX. Okay, so you may think that this is the outline of the lexical analysis, lex functions. So it is copied to lex y by the c. So in this simple code, you are declaring token count. And token count is incremented for every time for a single character, except a new line. And it is printed inside our main if you perform processing all the inputs by YYLX. Okay, so let me test this from your MSys. How can I switch this? In the MSys screen, we have seen that there's a file named token count. So token count.l, it is not actually token count, but it is just counting the number of characters. So you are printing the number of characters here. So if you want to, so let's just execute this. So you want to change the makefile. So instead of changing the makefile, you can copy the makefile as makefile token. Okay. So for makefile token, you want to use count. Or you can just make an internal token counter C can be created from, sorry, copy this. Created from copy or move next y by the C to QCCNT.C. Okay. And token count depends on TOK-CNT.C, and you need to change this as token count. And the source file is, instead of lex.y/c, token count.c. So this is the final target. So you have to make this as all. So all is token count. So your target is token count, and the token count is dependent on token count.c, and token count.c is dependent on lex.y/c. Once it is generated, you are going to move it to that file. So lex.y/c is dependent token count.l. So it is like this. So with this separate token makefile, you can make with F option, makefile.tok. So it is created. So token count, token count.exe. This is a line. How many tokens in it? So it is hard to decipher. Control D. So you know that this is up to here 5 is up to here 5 and up to here 14. So you have 14 characters in the first line. Okay. So actually not token. So it is 14 characters except new line. So how about this 14, 15, and there's 21 characters. So 21 characters in the second line. 21 characters. So in total, you know, there's 35. Okay. But can you see there's a new line is echoed here? That is a default action. So you can change this. Oh, sorry. You can change this token count.l. The default action may be deleted. Okay. So when you make it with new make file, what's wrong? So let's take a look. Sorry, it is for the new line character, not semicolon. Sorry for that. So make it again. Then if you execute this, this is a line. This is another. So can you see there's no new line is printed here? 31. So you can also count the number of lines. Token count.l. So instead of doing nothing, you can count line count can be incremented here. And the line count should be declared as 0. So the number of lines, you can type it more friendly. Number of characters like this. The number of lines like this. So you can print it in 3 digits. So line count. So you may return 0. Just make it. So let's take an input from. Let's clear this. Token count.exe accepting token count.l. Number of characters is 264 and number of lines is 21. Okay, so you can just compare this word count count.l. So number of characters is different. Why? Because you didn't count the new lines, but number of lines is same to here. So you can just summation of them 285. So exactly same to here. So in order to count the number of characters and number of lines correctly, the new line, you can also count the token count. So this may be included here. Then the output may be same to What's wrong? uh, I'm not sure why it is wrong. Number of characters. I don't know the reason. So you may debug this. Anyway, it is a bug. So bug of my input, I think, token counted N. So you may decipher what is the reason that. Okay, token count, line count. Seems not good. Seems good, but it is different to the actual output. Okay, so you may debug this. Anyway, in this way, you can count the number of characters and number of lines from here. So for another pattern, so let's take a look. Token count. This is not actual token count. So you can find that there's some of the integers here. So this is an integer. This is another integer. This is an integer. If you want to write 100, even though that is not a valid action 100, but minus 100. Okay, so that is a valid action. So you just make numbers. So in order to make numbers, you may add num count as 0. So you want to make numbers. So how can you do that? From 0 to 9, it is repeated. So in that case, number of count is incremented. Okay. So you can just print. So number of characters is different. Now number of integers. Number of integers is num count. Okay. So let's make this. So let's just execute it. I had 2 books, but let's make it 2 books. One is good. The other is bad. Control D. So number of integers is 2. Number of lines is 3. So how about token count? Exe is accepting token.l. And you know that number of integers is 10. So let me just check it. Add token count.l. 1, 2, 3, 4, 5. This is counting. 6, 7, 8, 9, 10. 10 is right. Okay, so it is very accurately count the number of integers in your code. Okay. Any questions up here? No questions? Okay. So let me show you today's problem. So today's problem is counting tokens except the command. So you have to process the one line command. So in this in the last laboratory, you have counted the number of tokens according to the following grammar. And the valid operators is including these things. And an identifier consists of alphanumeric characters starting with an alphabet, with an underscore is treated as an alphabet. So your scanner should handle single line commands. The commands can be either in C style or scheme style. A C style command starts from double slash up to the end of line. A scheme style one starts from semicolon up to the end of line. So write a program using flex to count the number of tokens of the input program given from the standard input. Your next input should neglect the commands. For example, the following input program. So you know that first one is a value token. It's a number. So you have to count this, count as 1. But for the second one, it is a command. So count to 0. Count to 0. For the third one, this is a valid literal negative number. So count 1. So you have to return 2. Your program should return 2. So based on the experiment, make a report with references, assignment number 8. You can write a report in Korean. Your report should contain the following materials: Lex regular expressions for the tokens, and your flex input file with the explanations, even though this flex input file containing the Lex regular expressions and what you have learned in this laboratory. So your program should read from standard input. The input consists of several lines, including valid scheme expressions. The program should neglect the white spaces, also neglect the comments. The program should print to standard output. The output consists of a single line containing the number of lexical tokens in the input. The program should be submitted to NeoESPA. So you have to submit .c, not .l. So do not forget select C as a programming language. The following shows two sample input and output. So this is similar to the last input. So you have to print 2. And this is similar to the one in the previous lab. So it is almost same to, so let me erase this a little bit. So let me count this. Opening parenthesis 1, define 2, opening parenthesis 3, 4, 5, 6. So you have to count 6. And you know that this is a C-style command. So you have to neglect this plus 0. And how about this opening 1, 2, 3, 4, 5, 6, 7, 8. So plus 8. How about this? 1, 2, 3, 4, 5, 6. So plus 6. Summing them up makes 20. Okay, so you should print 20 for this case. Any questions? So let me just change this a little bit. Count that down. So just neglecting this for numbers, just neglecting this. So you have to do not print this. So do nothing for new line. For the output, I'd like to just print token count %d with a new line of count. And all the others is just neglected. Okay, and I can make it if it is valid. So it seems valid. So I'd like to submit this to your NeoSPAM. So let me check your NeoSPAM. NeoSPAM here. So let me reshare this. How can I do this? Okay. Let me reshare this. This page. So I'd like to log in. So I changed it. In your homework, you can find that this is the handout, okay? And submit code using Lex. So you have to select file. So it is in Dropbox code compiler Lex token count the C. Okay, open it. And you select the C here, upload. So it is 0 points. So your TA is more change the file a little bit. So you have to at least add handle the comment, I think. Okay. How about the previous one? For the previous one, it is not possible for you, but for me it is good. So let me check this for upload. So can you see this? I have gained for 10 points, okay, with this simple code. Okay. So do you have any questions? No questions? Then thank you all for joining this lecture, and see you on the next Wednesday in offline classroom. Okay?